The next tool we would like to discuss is the most famous among the machine learning people. That's a scikit-learn. So this tool is available for machine learning applications in Python. It's very simple and efficient. Tools are provided for predictive data analysis. It is accessible to everybody and reusable in various contexts. The scikit-learn are mainly built on NumPy, SciPy, and Matplotlib. So it is open source as well, commercially available under BSD license. So various activities we can perform in machine learning through scikit-learn. So we can classify the data. So here we try to identify which category an object belongs to from the sample. The applications would be spam detection, image recognition, and many more to name. So here, when the question of spam detection comes, then we want to detect whether the mail is a spam or not spam. Yes, of course, we need human intervention before deciding what is spam, what is not spam. So the data is made available through human verification, which mail is a spam, which mail is not a spam, and all that. So that way, uh, data is available, and we make a model to learn. So that's a supervised learning. Same way, object recognition, image recognition. Spam detection is a binary activity, whether it is spam or not. And image recognition, maybe object recognition, so may contain many objects. So it's a multi-dimensional world, whereas spam detection is a binary output. So that's what we can do in classification, and scikit-learn has got very powerful tools with it so that it can help us. The algorithms defined in scikit-learn for classification are the SVM, support vector machine, nearest neighbors, random forest, and many more. Yeah, then comes another application where we have an input and output data, and we would like to somehow find out the relation between input and output and put that in some analytical form. So when it is required to condense the big data into one expression, then what we require is regression. So regression is predicting a continuous valued attribute associated with an object. So here we try to identify a relationship between input and output in the form of mathematical expression, and then in future for any given value as input, we would be able to predict what its corresponding output could be. So that's regression. So the applications may be drug response, like different values of doses given, then what happens to the output, how the response is, or for different treatments, so how many days it took to get cured and all that. Or you can look at the stock prices So stock prices, all these are time based, so it can work in a time series. Some are time series, some are not. So whatever we are able to find an expression which relates the input with the output, and that expression is handy for predicting any output for the given inputs. The commonly used algorithms for regression defined under Scikit Learn are support vector regression, nearest neighbors, random forest, and many more. A very big series of tools are available. So when we get into Scikit Learn in detail in future, we come to know what all are available. It's just a glimpse of it we are giving now. So the previous two examples were for supervised learning where output was known, but now there is situation where only inputs are available, but we don't know what the outputs are. When that's a situation, then we are dealing with learning which is called unsupervised learning. Here we have only the features, but we don't have any labels to it. So in such case, we would like to somehow cluster these objects depending on some features. So that's a automatic grouping is what to be done. Uh, this group should contain the similar objects into sets. So that's clustering. Application customer segmentation. So looking at the data, you would like to segment the customers into various categories and then grouping experiment outcomes and so on. So many applications we have for this. And scikit-learn has got a big world of algorithms defined in it, which is very much available for us to use, such as k-means, spectral clustering, mean shift, and many more. When we are dealing with real-time data, then the data will contain, if you talk data as a table in our database language, then it contains many features or many columns. These many columns are the variables. The more the variables, the more computation is needed to reach some goal. So the first aim of any data analyst is to identify whether all the features are equally required or not. If not, then what to do? If yes, what to do? How to identify which feature is required, which is not required, and all that. It's really a big task for any data analyst. And here the scikit-learn will come to our aid. It has got a large number of functions available with it. So like principal component analysis, feature selection, non-negative metrics, factorization, and many more functions are available. This is the application of reducing the dimension is one. You can go for a visualization because the less the dimension, the higher chances of putting them on the screen visually. If it is very large number of data, then we cannot see the relation between the input and output, each parameter wise on the screen, projecting it as a visual thing. But if the dimension is reduced, yeah, of course, the visibility becomes easier, and the more we visualize, the more ideas we get whether they are related or not related and all that. So that gives us a better picture what data we are working on. Are they easily classifiable? Are they easily can we go for a linear regression or non-linear regression or so on. So many issues are related with the higher dimensions. The more dimensions, more is the problem. Exponentially, the problem rises as the dimensionality increases. So it is always advisable to work with the least possible dimension for the given problem. So need to minimize the dimensions to the least possible required to solve our problem. Then we have tools for model selection. So comparing, validating, choosing parameters and models possible through scikit-learn tools. Application, improved accuracy via parameter tuning. So when you're selecting the model, if we do it manually, we may not be able to find the best possible model for our current problem. But if we make use of model selection facilities given by scikit-learn, then this finding the best model and parameter tuning, everything is done automatically. So almost 99% of our headache comes down while working with machine learning problems. So the algorithms defined under scikit-learn are grid search, cross-validation, metrics, and many more. When the data is made available to us, so it need not be in a best form, so it may contain many missing values, it may contain many wrong information, may be having redundancy, so the data may be repeated or unnecessary features may be there. So all this we would like to solve. We want to make the data clean before doing any work over it. So scikit-learn allows all these pre-processing activities very efficiently. So we can extract the features and normalize them so that the final outcome is the most efficient possible. So applications for these tools are transforming input data such as text for use with machine learning algorithms and many more. So you can clean the data. So algorithms, we have pre-processing algorithms, we have feature extraction algorithms, we have many more. That's the better way of presenting what scikit-learn can do. You can keep on talking hours on this, but a picture definitely worth more than 1,000 words. So you can see that scikit-learn can be used. It has its own data set with it, and then you can use scikit-learn for pre-processing the data cleaning, data integration, data transformation, data scaling, data imputation. All these are possible with scikit-learn. Then before continuing any activity, we need to explore the data. So exploratory data analysis is easily done through scikit-learn. Then machine learning evaluation we can do through validation, through confusion metrics, through error analysis, through performance report like F1 score or area under curve, and many more. The other side, we can see that the dimensionality of the data can be reduced to a simpler problem. A bigger problem can be first simplified into a simpler problem before actually solving it. So the machine learning models are there. So like regression, classification, clustering, all such things are also available with it. Yeah, if you're talking about regression, then there are so many functions available for regression. In the previous slides, we were not able to put everything. So this one gives a very simpler version of presenting what all regressors are available. So there is something linear model. Under linear model, we have linear regression, lasso, Lars, ridge, Bayesian ridge, and so on. So we can use a tree type of regression where decision tree regressor is used. Support vector machines can be used for regression. So that's a linear support vector regressor. So looking the properties of the neighborhood, we can see that a neighbor's regressor is there. Then we can go for ensembling. So random forest regressor, boost regressor, gradient boosting regressor are some of them under ensembling models. Same way for classifiers, we have linear model, tree model, support vector machine, name Bayes measure, neighbors, ensemble methods. So these are the things available for classifiers. And for knowing whether we are doing right or wrong, so metrics aren't required. So for classification, the metrics used commonly are accuracy score, balanced accuracy score, F1 score, precision, recall, and along with many more are also defined. And under regression, commonly used are mean absolute error, mean squared error, R square score, and many other things. So these just a humble introduction about scikit-learn. It's as it is a big world which is useful for every activity of machine learning. So we look forward to get deep dive into this when we are really into machine learning activities. So till then, see you. Wait for, please keep watching for the further videos on